Hi everybody, welcome to NuttX channel. I was really busy recently and didn't have the chance to create a new videos, but today I'm here to show how to add support to your board to the numeric display like this one, powered by the Max 7219. So I will show step by step what you need to do to create the needed files to include support to your board. So open the Linux terminal, enter inside NuttX space, NuttX, execute make dist clean to clear previous configuration. The driver source code is inside drivers LEDs max 7219.c. Open this file just to understand a little bit how it works. Basically, we have the Spie functions used to communicate with the Max 7219, the operation to open and write to the driver, and some important point to note, to pay attention, is the SPI select. When you select the device, you are selecting it like an SPI device display. In this case, it will be address like display 0. This is the most important function of this drive, the write function. Basically, it just gets the data, the bytes received from the user space, and decide what to do with these bytes. For example, if the bytes are numeric values, for example, between 0 and 9, it's just send it like a number to display. The coding inside the display also supports some special characters. For example, the minus signal, the minus symbol, sorry, the letter E, the letter H, the L, and the P. So you can create help and display help and so on. But it doesn't support all the letters that should be supported by 7-segment display. For example, there is no support to letter C. It was possible to create these letters, but not using the default engine, the default decode, the default code B engine inside this chip. You should address all the individual segment and create some like a table where you have the letter you want to show or the number you want to show, and each segment you want to turn on. But this drive is different. It's using the internal engine of the Max 7219. And finally, it's also an important function. This is the function used to register the device driver. So you call Max 7219 LEDs register, passing the device path where you want to create the file. For example, /dev/display 0 or disp 0 in this case. I will show ahead. And you pass SPI dev structure, call it SPI. This XPI structure is in fact pointer to your SPI port in your microcontroller. For example, if you have 3 SPI ports in your microcontroller, you can select what SPI port you want to use. Okay, so basically this is the overview, a fast overview over the driver, about this driver, sorry. And I will show what files you need to create to support it in your board. I will use the STM32F103 minimum board because this driver doesn't use too much memory, so we can use a low-end board like the STM32F103 minimum board or Blue Pill. And you can, after watching this video, you can create the same board to port to the STM32F4 Discover board. Okay, so we can exit. The first thing you need to do is enter inside your board and create the needed files or modifying the needed files. We need to create a file and modify at least 4 files. So enter inside configs STM32F103 minimum /src. As you can see, there is already STM32 max 2219.c here. But this driver is not for the numeric display. It's for the matrix .LEDs matrix. I will open it to show you the difference. So, as you can see, it is include the LCD, not LED driver, because for the dot matrix, the driver is used as a display, as a graphic display, not a 7-segment display. And the driver is not the driver LEDs max 2219. Okay, so the first thing to do is to create the driver to initialize the SPI device. So we can base on some other file that use the SPI to initialize. This way we don't need to create all the lines step by step. I will show, for example, the APA102.c. This is an LED driver as well, but it's for LED string or LED strip, sorry. Basically, we call the header file to APA100 and verify if we are using the SPI1. In this case, we use the SPI1 as well. So here we put the port number, SPI1. And this is the initialization function. The initialization will be very similar. We just need to modify the function name to be max 7219 init, So let's show how to do that. So we can copy this file to STM32 max72. We cannot use the same name because there is one with this name, but we can put the num in the end because it's numeric display. So the file will be the max 7219. We can open it now. So we can just replace the name here, APA 102 with max 7219. Okay, it modified all the files, all the names, but we need to double check because some names could be different. Also the uppercase we need to change. For example, APA 100 with max 219. So basically that is it. We don't need to modify too much in this file because the LED initialization for all other drivers is very similar. Now we need to modify the make file to compile this file. Copy the name here and I make file. We can copy these lines, these 3 lines, and modify this one to max 7219. And here we put the file name we just copied. Okay, that is it. Now we need to include the initialization function inside the board initialization. So open the max file again and copy the initialization function here. We just call this function passing the device path we need to use. So now we need to edit the STM32 bringup.c to call this function. Inside the STM32 bringup, we just select one place to put it. For example, here the initialization is very similar to this one, so we can copy this and put it here and modify the config to LEDs max 7219 and the function name. Let's pass the name here and the the device name will be disp0. And if it fails, we show fail to initialize max 7219 and the error number. Now we need to modify the STM32 SPI file to detect when the driver want to drive the chip select, and we need to define the chip select as well. And so let's do it now. SPI.c. As you can see, there is a config LCD max 7219 to dot matrix display, so we can copy it and modify to use with the LEDs display. And here we change from LCD to LED chip select. Okay? And because we changed the chip select pin name, we need to create this chip select pin. Now we need to change the chip select function here. Here we can create a copy. Put here, change to LEDs. Okay. And here we change the chip select pin to LED chip select. So basically that is it. We can save and exit and open the board file configuration. This one. We need to find where the chip select are defined here, and we can use this one as base. We can change the pin number, but I will use the port A pin 4 as well, and I will just change the name from LCD to LED chip select. Okay, it is done. Now we can return to root directory. Now we can configure the board. Tools, configure SH, STM32 F103 minimum /NSH. Execute make menu config. Enter inside system type, STM32 peripheral support, and enable SPI1. Exit, exit again. Enter inside device drivers, LED support, and enable max 7219 numeric display. Exit, exit again. Enter inside application configuration, NSH library, and just double check if have architecture specific initialization is enabled. Okay. Now we can exit and save. Execute make to compile the source code. we get a warning and an error. The right name should be max 7219 LEDs registered. So we need to modify the file to use this name instead the max 7219 register. And this one, the warning is easy to fix. We can just copy the function name and include in the board config, in the board header. So configs stm f103 minimum src, open the max file and copy the function name here. Now open the board header file and we can find a good place to put it. For example, here we can use the same structure, just copy it and put it here. Change the name, the comment name here. And the config, and here and here we can pass the function name and okay, and save and exit. And this one we need to change to max 7219 LEDs register. So just modify the register function name here and try to compile again. Very nice, the compilation finished correctly. Now we need to flash the firmware inside the STM32.103 minimum board. So plug the programmer and the power supply over USB to the board. Okay, let's do it. I have the Control L to move up. I have the OpenCD command here. Okay, the firmware was flashed. Let's run Minicon now. Okay, reset the board. Very nice. Let's see if the device driver disp0 was created. Okay, it was created. Let's send echo 123 to dev disp0. Very nice. Basically that is it. I hope you had enjoyed this video. If you are not subscribed to NuttX channel, please subscribe and click in the bell icon to receive notifications when I post a new video. See you. Bye bye.